Okay, so some algebra now with quadratic equations, and we've got to remember a few things. Quadratic equations are always of the format so many x squared plus so many x's plus a number is equal to 0. That's what a quadratic equation looks like. And when we're factorising, we have to remember that it's going to be brackets. And because it's a quadratic involving no common factor, so there isn't a common factor to all of this, then it's going to be 2 brackets. So we know that the factors are going to be 2 brackets. Must have x at the beginning because we know that x times x is x squared. The 27, well, the clue is that that's got to be made by 9 times 3 or 27 times 1. And we can see that 27 and 1 doesn't nicely give us negative 12, but we can see here that if we've got negative 9 and negative 3, then negative 9 plus negative 3 equals negative 12. So we've found the factors of 27. That will give us the middle term of negative 12, or the middle coefficient of negative 12 when we add them. So x take away 3, x take away 9. Okay, our check would be to give x a value. So we could say what happens when x is worth 1. So we end up with 1 squared, take away 12, plus 27. So 27 plus 1 is 28, take away 12 is 27, 28, take away 12 is 16. So we've got 1 take away 3, which is negative 2. And then we've got 1 take away 9, which is negative 8. And negative 2 times negative 8 happens to be 16. So our check works. Okay, so that's one way of checking that the factors work. But factorise, find the factors, put them into brackets, go to quadratic and so forth. The question then says solve. Well, what we should realise is that this is the same as that bit there. So we can change this into its factors. And because the only way you can make 0 from multiplications is by timesing by 0, then either x take away 3 equals 0 or x take away 9 equals 0. Well, x take away 3 equals 0 tells me that x must be worth 3, and x take away 9 equals 0 tells me that x must be worth 9. So our answers here are x is 3 or x equals 9. And again, can't emphasize enough, guys, we have to check. So we check by saying, well, what happens when x is 9? So we've got 9 squared, take away 12 times 9, plus 27. So we've got 81, take away 108, plus 27 equals 0. Yes, it does. So we're happy. Okay, 27 plus 81 is 108, take away 108, 0. And we can do the same with 3. So 9, take away 36 plus 27. Well, 9 plus 27 is 36, take away 36 is 0. Okay, so factorise. Again, we've got a quadratic here. Y squared, take away that. So we know it's going to be 2 brackets. But what we should realise with this one, rather than thinking about factors that go for 100, which would be 10 times 10 and so forth, but it had to be negative 10 and positive 10, and 10 take away 10 equals 0. Then we should realise that this is called the difference of 2 squares, and the difference of 2 squares has its common pattern. That is going to be a plus b times a take away b. So in this case, the a is y, and the b is the square root of 100, which is 10. So y plus 10, y take away 10. Again, we should check really and say, what if we said that y was worth 2? Would that give us the same answer and so forth? It's only worth 1 mark though, so really it's about the difference of two squares, and recognising that if you square root both of those, that's what goes inside the brackets. One's a plus, one's a negative, because you'll end up with 10 take away 10, which is 0 y's. Okay, so that's a little bit on quadratic factorisation and solving equations using a factorising technique.